Hi, my name is Sebastian Matteau, and today I want to tell you all about unpacking tuples and other iterators in Python. Now, let's start with the first things first. What is an iterator in Python? Well, an iterator sounds kind of like a technical, complicated term, but it's really not. An iterator is just any kind of Python object that has multiple elements in it. Now, if you know a little bit of Python, you've encountered iterators before. For example, here are a few iterators that you will see all the time. Tuples. So here we have a tuple of the elements 1, 2, and 3, so a tuple of int values. A tuple is indicated by these parentheses or simply by values separated by a comma. So depending on the context, the parentheses are needed or not. Below that you have a list. A list is indicated by square brackets around the elements. So this is a list of 1, 2, and 3. Tuples and lists are very similar. The main difference is that a tuple cannot be modified. It is what they call immutable. Whereas a list can be modified. So it is mutable. In other words, once you have defined a list, you can change the elements in a list. Whereas once you have defined a tuple, you cannot change the elements in the tuple. You would have to create a new tuple with different elements. But other than that, they are very similar in many ways. Then we have a dict, which is also an iterator, but a kind of a special one, because a dict is a sequence of key value pairs. So in this case, we have the keys are the A, the B, and the C. The values are 1, 2, and 3. And the key A maps onto the value 1, the key B maps onto the value 2, and the key C onto the value 3. Now, so the elements in this dict are these key value mappings, right? So the first element is A mapped onto 1, the second element is B mapped onto 2, etc. So it's a bit of a slightly more complicated type of iterator than the tuple and the list. And then finally we have the set, which is also a standard iterator in Python, but not used all that much. It is indicated as a dict by these curly braces, and essentially it is an unordered collection of unique elements. So it's like a mathematical set, right? Each element can occur only once, and they don't have any specific order. Now, so those are the iterators, and you've undoubtedly encountered iterators before while programming with Python. Now, how do you create an iterator? For example, here in this tutorial, I will mostly use tuples. So how do you create a tuple? Well, you simply do an assignment, and then on the right-hand side of the assignment, you create a comma-separated list of the elements. So this is a tuple of 4 city names: Marseille, Groningen, and Buenos Aires. Now, if I print out cities and I see what kind of type it is, you will see that this is the cities variable, and it is a tuple, right? So it is that's simply how you define a tuple. Very simple. Now, what is kind of special in Python is that you can also have multiple variables on the left-hand side of the assignment, right? Having multiple variables on the right-hand side of the assignment, as here, is not really that special. But here on the left-hand side of the assignment, we also have multiple variables. And then we get what is called unpacking or multiple assignment. So you can basically see what's happening here, right? Marseille gets assigned to city 1, Groningen gets assigned to city 2, Buenos Aires to city 3, and Mumbai to city 4. Let's print this out. Up, city 1, city 2, city 3, city 4. Let's run it. And you see it works. City 1, Marseille, up. Now, here we have actually explicitly defined the tuple, but we can also simply put the cities variable here, right? Cities has these 4 elements in it, and we can also just unpack this variable cities onto these 4 variables here on the left-hand side. And this is tuple unpacking multiple assignment. A very, very cool trick in Python. Now, here in this case, this cities tuple is flat, right? There is no hierarchy in it because each element in a tuple is just a single string. But you can also have nested or hierarchical tuples, as you see here. These are the cities grouped by continent, and then you see that Marseille and Groningen are grouped together in a tuple. The next one is not a tuple, but it's just the name Buenos Aires, and then we have another single name Mumbai, right? So this is Europe, this is South America, and then we have Asia. So you could say the hierarchy here is we have first a tuple of 2, x, y, just to kind of indicate the structure, x, y, and then we have a single value, a and b, right? So that's kind of the structure that this nested tuple has. It is nested because we have a tuple inside the tuple. Now, we can unpack this in a way that we did before, and then you get, for example, this. South America, Asia is cities by continent. Let's print them out. Europe, print South America, print Asia, up. And you see that this works, right? So this first tuple gets assigned to Europe, Buenos Aires gets assigned to South America, and Mumbai gets assigned to Asia. That's just the same that we did before. But what we can do, and that's pretty cool, we can unpack the European cities in one go by essentially having the left-hand side of this assignment mimic the structure of the tuple on the right-hand side, right? So we just indicate, okay, Europe is actually a tuple that consists of 2 cities. And then we unpack that right away. Print Europe 2. And now you see we have unpacked this nested iterator, this nested tuple or hierarchical tuple, in one go into 4 variables, simply by making sure that the left-hand side of the operator, the left-hand side of the assignment mimics the structure of the right-hand side of the assignment. A very cool trick, extremely flexible, extremely powerful, very Pythonic, I'm inclined to say. Now, we can do more things with iterators and unpacking. Say that we have an iterator and you don't know how long the iterator is, right? So far we know we've defined the iterators ourselves, the tuples ourselves, so we know that they contain 4 cities, but say that we don't know that. Then we can do what is called star unpacking or extended iterator unpacking. And this, I should point out, is only supported in Python 3. So this will give you a crash if you try it in Python 2. And the idea is simply this, right? Say that we have city 1. And what we do, I'll just type it. What we specify here is that we want to get the first city from the cities tuple, assign it to city 1, and everything that remains gets assigned to rest, which becomes a list. If I print this, you will see that this works. Up. You see that Marseille gets assigned to city 1, and rest becomes a list that contains the rest, right? All the other elements from the tuple. We can also say that we want to, for example, take the last city 4. Then we can also do this. Basically, we say, okay, the first city should go into city 1, the last city should go to city 4, and everything in between should go to the rest, right? So rest becomes Groningen and Buenos Aires. Very flexible. We can even say, okay, we know that there are 2 cities in the beginning, also 2 cities in the end, and everything that remains should go to rest. Up. And now you see that rest actually becomes empty, the empty list, because we have only 4 cities in our cities tuple, and they've all been eaten up by these variables, city 3, city 4, city 2, and city 1, right? So, and this star operation, this star unpacking is a very powerful way to unpack lists or tuples if you don't know in advance how long they are, right? And you just basically unpack, you store everything that remains in a single rest variable. Now, so far what I've done is use tuples. Right? Cities has been a tuple here. But this unpacking works with any kind of iterator. Tuples, lists, dictionaries, sets, but also iterators that you define yourself. So here we have a generator function, 1, 2, 3. And I'm not going to explain the semantics of generator functions here. Basically, you should think of this as a custom function that generates the values 1, 2, and 3. If I say, okay, for I in 1, 2, 3, print up. You see the idea, right? We call this function and we can loop through this function as though it is a list or a tuple or whatever. It is an iterable, a generator function, and it returns 1, 2, and 3. Now, even here with these kinds of things, we can still use unpacking exactly in the way that we can also use it for tuples and lists and what have you. Simply because unpacking is a very generalized property of Python, right? So we can unpack the first value that is yielded goes to A, the second value that is yielded goes to B, and the third one goes to C. That's pretty cool. You have to be a little bit careful though, because iterators are allowed to be infinite. So far we've seen iterators that are all finite, right? In this case, the 1, 2, 3 generator has a length of 3. But here we have an iterator, again a generator function, that is infinite. So it generates an infinite range of numbers from 0 up to infinity. So to demonstrate how it works, what we can do is for I in range or in infinite, print I. Now, if I would execute this, IPython would freeze, right? Because it goes looping through an infinite range of numbers. So what I say is if I is 3, for example, or 5, whatever, break. Just so to make sure that the loop breaks after a while. Up. You see it works. We get a list 0, 1, 2, 3, 4, 5, or a list. We get a range of numbers 0, 1, 2, 3, 4, 5, etc. But if I hadn't broken with this explicit statement, it would have gone on forever. Now, how can we unpack this? Well, essentially we can't. So if I would say A, B, C is infinite, it says too many values to unpack, expected 3, right? Because I expect to unpack 3 variables. Now you could think, okay, let's put the rest into a rest variable. If I do this, the universe will break, essentially, because it will unpack the 0 into A, B becomes 1, C becomes 2, and then the Python interpreter will keep looping infinitely, adding numbers and numbers to the rest variable. So I'm not going to execute this because it would actually freeze. In other words, tuple unpacking with infinite iterators either does not work or it will freeze your computer. It's generally a bad idea. So if you're going to unpack things, make sure you're dealing with finite iterators. Okay, now I've already mentioned that a dictionary, a dict, is also an iterator. It's also something that you can loop through. A dict is as I already said, an unordered collection of key value mappings, where, for example, here the key Sebastian, the name, and the age is 34. And the elements of this dictionary are these key value mappings. Okay, I say unordered, and that this means that obviously there is some kind of order. Everything always has to have an order, but the order is unpredictable. In Python 3.6, the order is actually preserved. That is a new feature of Python 3.6, but the Python developers explicitly say that you should not rely upon the fixed order of a dict object. So treat dict objects as though they have no particular order. Now, let's first take a look what happens if I loop through a dict. For name in names and ages, print name, right? So if you loop through a list if you loop through a dict in this way, you get the keys, only the keys, not the values. So here you get the key. You actually see Maria comes first, right? There you see the fact that the order is not preserved. Then Boufie, then Sebastian. Now, following this principle, you can already kind of predict what will happen if I do this. Name 1, name 2, name 3 is names and ages. Print name 1, name 2, name 3. Up. This works, right? So I can unpack a dict directly, just like I can unpack a tuple and the list. But what I get are the keys, only the keys, so the names in this case. Name 1, name 2, and name 3. So say that you want to unpack not only the names, but also the ages in this case. So not only the keys, but also the values. You can do that, but you have to make use of the fact that dict.items, that I'll just print it out, names and ages.items, is the items function returns tuples of keys and values. Now, once we know that, we can use that to do this kind of nested unpacking. Namely, we can say name1, age1, name2, age2, right? Get the trick. Name3, age3. And then we say print up is is years old. Name1, age1. 2, 3. 3, 2. And there we go. So this works. Maria is 20, Boufie is 7, and Sebastian is 34. Okay, and this works because the items function returns a nested iterator, you could say, a list of tuples, and we simply mimic the structure of this nested iterator on the left-hand side of our assignment, and therefore it works. So Sebastian, well, the first name goes to the name one, second, the value, the age goes to h1, etc. Right, so you can properly unpack dictionaries as well, but if you want to get the values, you need to use this items function. Okay, now finally, let's take a look at a set. Not because you'll probably use a set all that much, but unless maybe if you're a mathematician, because it's kind of a mathematical construct. But just to show you that it also works with sets, let's take this Fibonacci series, the first 5 elements of the Fibonacci series, and let's print it out. Now here we see something weird, right? We've put in 1, 1, 2, 3, 5, and what we get back is 1, 2, 3, 5. The reason is simply that a set consists only of unique elements. So if you repeat elements, they will simply not be added, right? So if I do this, it will be the same set. And you can also simply A, B, C, D is Fibonacci. Print A, B, C, D up, and it works, right? So we can also unpack sets just in exactly the same way that we unpack tuples and lists, and just assign them to A, B, C, and D, right? And we have 4 variables because the set here consists of actually only 4 elements, because the 1 is a duplicate, so counts only as 1 element, right? Now, okay, that's all I had to say. I think now you know everything pretty much there is to know about unpacking or multiple assignment in Python. So thank you very much for your attention.